In this video, we're going to talk about preconditions and postconditions, kind of some computer sciencey terms right there. We're going to talk about how we can use assertions of postconditions to make code easier to reason about. And we're going to talk about how we can use those things to find our bugs sooner, or hopefully prevent those bugs entirely. So let's go back to the specification that we had for our maximum method. And I've grayed out a bunch of this and just highlighted the things that have to be true before the method executes successfully, right? So the input has to be an array of decimals. The array must not be null. The array must not be empty, right? We know all of that, right? And so in the sort of computer sciencey term for this thing is these are the preconditions of the method. These are the things that must be true before the method can successfully return a result, right? Now, sometimes if these preconditions are not met, right, if the array isn't even an array of decimals because it's an array of integers, the precondition won't be met because the program won't even compile. Some of these things are conditions that are not met at runtime, like the array not being null or the array not being empty. The point is, if any of these things are not true, then either the program won't run at all or the caller has a bug, right? So these are the preconditions, right? Now we are very vague about the things that have to be true after the method is done, right? So let's take a look at those. We know that the purpose of the method is to compute the maximum element of an array of decimals, and that the output is a decimal value, and that there are no side effects, right? That's pretty vague, right? So these are the things that have to be true when the method is done. A decimal has to come out, and nothing else has to have changed, right? Now our bug previously was a violation of what is truly a postcondition of this method. It's not the maximum element of the array, right? But how can we be a bit more crisp about that? Well, I'm going to try to crisp up this output here, right? I'm going to say the output needs to be a decimal value that is, first of all, in the array, and second of all, there is no element in the array that is larger than the returned value, right? So these two conditions much more precisely capture what it is that we expect this maximum method to do, right? These in a sense, recapitulate the purpose, right, that I stated up here. This computes the maximum element of an array of decimals. Well, what is the maximum element? It's an element, for one thing. It's in the array, and it's maximal, right? Nothing else is bigger than it. Our bug last time violated this postcondition, right? It violated it violated the first condition, that the element that is returned actually be an element of the array. The array that we saw only had one element, negative 456.7. The value that was returned was 0. That's not an element of the array. The second postcondition was met. No element of that array was larger than 0, but the first postcondition wasn't met, so something was wrong. Something was wrong with our method. So basically, the idea here is the method is correct if satisfying the preconditions guarantees that the postconditions will be satisfied. So I want to try to capture some of this in code, right? So we have this first condition. This thing has to be in the array. And we have the second condition. No element of the array is larger than this thing. And that sounds like the kind of thing we could write a method about. So let's write a specification, because that's what we do. All right, I want a method. Its purpose is I want to determine if a particular value is contained in an array of decimals. I'm going to call this thing contains. It's a static method. Everything that we're doing in this course is static methods. Its input is going to be an array of decimals and a decimal value that we want to check to see if it's in the array. The output will be a Boolean, either true or false. True if the element is in the array, and false if it is not. No side effects. The array must not be null. Now, before we said the array must not be null and the array must not be empty. In this case, we can handle empty arrays. If you say, is this value in this empty array? Then we can quite sensibly answer, no, it's not. That array is empty. It doesn't have any values in it. Now you might say, well, couldn't we do the same thing for null? And I am much more inclined to throw an exception if somebody gives me a null array, right? If somebody says, is this value in this array? And they don't even hand me an array, not even an empty array, a null reference, the reference that refers to no array, right? I want to say, that thing's not an array. You shouldn't even be asking this question. You have a bug, right? I always try to be as strict as I possibly can to make sure that my caller is doing the right thing. All right. So we have a specification for this method contains, and so let's go to some code and see if we can write this thing up. Right? So I have made a copy of all of the code from the previous episode, and I have reintroduced the bug that we had where the biggest so far variable was set to 0. Right? So I've undone the fix for that, but everything else is the same. All of the test cases are still there. So let's take a look at this method. It returns true if the values array contains the value. It returns false otherwise. I've got a little comment just kind of restating what the purpose line of the specification was in maybe a little bit more language of C#, right? Saying it returns true, otherwise it returns false. All right. So we know how to make a method. We start with static. Then we give the return type. The return type is bool. The method's name is contains, and it's going to take 2 parameters this time, an array of decimals called values, and a specific value that we'll just call value for lack of anything better to call it. Our specification called for the method throwing an exception if the values array was null. So we'll do that right away. We'll just say if values is equal to null, throw a new argument null exception. And we double check, because remember from a previous episode that this is confusing. Yes, we want the parameter name first and then the message. Right? So the parameter name is values, and then the message, the array must not be null. Once we've gotten through the check for null, we know that this thing is not null. If it were null, then we would have thrown before we got here. So we can safely dereference this array. Right? It might be empty, in which case we will simply skip over this loop, right? Because there are no items in values. So we'll just skip over it and return false. If there are items, then we will just go through this thing. We'll say if item is equal to value, then return true. Now, you notice something here that we have not seen this before. We have here a method that has 2 returns. What happens if we return from the inside of a loop? Well, what's going to happen is suppose we start iterating through the array, and we go past the first item and the second item and the third item and the fourth item. And then on the 5th item, we discover, oh, yes, this array does contain the value that we were looking for. At that point, we abandon the loop entirely. This is like a super powerful break. It just says, this entire method is done. We're not going to keep on going through the loop. We're going to return true back to our caller immediately. If we make it all the way through the loop, if we go through every possible item in this array, and we don't find one that is equal to the value that we want, then we're going to return false because this thing wasn't found. Right? Now, some people think that it is inelegant to have methods that have 2 returns. And I can see that school of thought. That does make some sense to me. And I do try to structure complicated methods so that they have as few returns as possible. But on the other hand, I also try to avoid complicated methods. The bad thing about returns is not the bad thing about multiple returns is not that there's 2 of them or multiple of them. The bad thing about them is that you can't look at the code and easily reason about when it's going to stop executing and return its value to the caller. This piece of code is so short, it's less than a dozen lines long, and it easily fits on one page, that you can just look at it and you can see, oh, it returns true in this case, it returns false in that case. Now, there are a bunch of things that we could do. If we really wanted this thing to not have 2 returns, we could, for example, say, we could have a variable up here. We could say bool result is equal to false. And then if the condition here is met, then we could say result is equal to true and break. We can break out of the loop. Right? And then get rid of that return. OK, so I just made some edits to this piece of code. Is this now correct? Well, let's kind of look at this thing and see what it does. If we set bool is equal to result is equal to false, then we run through everything. If it's true, then we break out, and then we return false. OK, I should not be making these edits so fast, apparently. I should be returning result right here. So again, you see how these bugs happen, right? People are coding quickly. They make a change. They think that they have worked out all of the implications of that change. They have not. And the code no longer does what you think it should. This is why it's so important to have tests, right? So that every time you make a change to a particular piece of code, you can run the tests again, make sure that you did not mess anything up. Now, we could write a bunch of tests for the contains method, and going through the same exercise that we went through for the maximum method, figure out a bunch of different kinds of arrays, and we could say, OK, well, some arrays have many elements, and some have only a few, and some are empty, and all of that. I'm not going to go through that exercise for this method, but you could see how we could do that. Right? All right, so what about our other method? We said that we had two conditions. We wanted to have the condition, does this array contain the element that we are returning for the maximum? And also, is this element greater than or equal to every element that is in this array? Right? So that seems like something we could also write a method for. Right? So let's write a specification. Well, what's our purpose? We want to have a method that determines if a particular value is greater than or equal to all of the elements of an array of decimals. Right? We'll call it is greater than or equal to all. This method has a really long name, and I love it when methods have long names. I want the name to be descriptive, I want it to be clear, and I want it to be accurate. And is greater than or equal to all? It's very clear. Right? What kind of method is this thing? It's a static method. What are its inputs? Once again, we have an array of decimals and a value. The output is a Boolean, no side effects, and the array must not be null. Right? So again, we should reasonably be able to say, here's an empty array. Is this element greater than or equal to every element in the array? And figure out some sensible answer to that question. So let's take a look at the code for this thing. I've got a method, a static Bool returning method called is greater than or equal to all. It takes an array of decimals and a value. And so here's what we're going to do. OK, if the values array is null, then we're going to once again throw an argument null exception. This is just boilerplate code. We have seen this several times before. All right, so we want to say, is this value greater than or equal to every other value in this array? Well, if it's smaller than any value in this array, then the condition must not be met. Then it must be false. So we're going to go through every element in the array. We're going to say if the given value that was passed in is smaller than an item in the array, then clearly it's not greater than or equal to every element in the array, so we return false. If we manage to make it through every element in the array, then we're going to say, yes, true. It is true that this element is greater than or equal to every other element in the array. Now, here is a subtle point, right? Suppose the array is empty. We did not throw an exception if the array was empty. If the array is empty, then this loop is not going to run at all. Right? We're not going to enter the body of the loop because there are no elements. And so we're going to return true. And so the question is that the right thing to do here? And you could argue it either way. You could say, well, there's no element that's smaller, so this thing must be greater than or equal to all of the elements. Or you could say, well, that's kind of a weaselly way to look at it. It seems kind of strange to say this element is greater than every element in this array when the array doesn't have any elements. That seems like maybe it's a bug. So I would be happy to argue this one way or the other. I think this implementation is reasonable. I think also changing the specification to say that the array had to be non-empty would also be reasonable. OK, so and again, we would want to write test cases for this method is greater than or equal to all. And again, for the purposes of time, I'm going to skip doing that for this exercise. All right, so let's go down to our test verification method. You remember this from the previous video. We have a method here that takes in an observed decimal value and an expected decimal value and the name of a test. If the expected value is equal to the observed value, then it says the test is passed. If the expected value is not equal to the observed value, then the test has failed. There's a concept in computer programming called an assertion, which is a sort of a generalization of this idea. And there's a whole bunch of methods in C# that are available to you to help you do assertions. And they are in the system diagnostics namespace. And this one, unfortunately, is not included by default when you create a new Visual Studio project. So I had to go in here and write this in here. And the method that we're going to look at is called debug.assert. And so let's take a look at an example of that. Right? So we have our maximum method. Right? You remember this is the one that had the bug in it. What do we do first? We check to see if the preconditions are met. Right? We check to see if the array is non-null and non-empty. And then we go through our algorithm that tries to figure out the biggest thing we so far. I have added here two post conditions. Right? So I'm going to call the debug.assert method. This is a static method on the debug type in the system diagnostics namespace. And debug assert wants as its argument something that is Boolean. You see if we point to this thing, it says it's a void returning method, and it takes a Boolean that is its condition. So this call is the argument to this call is itself a call to the contains method. So what we're saying is we are asserting that the values array actually contains the biggest one that we've seen so far. Right? So recall this is one of the post conditions of our method, right? That the thing that we are about to return is actually in the values. Right? Now we know this is going to be violated by one of our test cases. So let's step into this and actually see what happens. So we're going to step into main. We'll call test maximum. Step into test maximum. We initialize all of these tests. I'm going to skip over the one positive test. I'm going to step into the one negative test. Right? So the first argument to verify test is a call to maximum. So when I hit step into, we're going to step into that call to maximum. We verify that the values array is not null. We verify that it's not empty. We say biggest so far is 0 because I've reintroduced this bug. Now we go through every item. We discovered that the item that we're looking at here is negative 456.7. That is not bigger than the biggest thing we've seen so far. We've gone through every element in the loop. Now we are going to assert that the values array contains the biggest element so far. So if I hit step into here, we will step into the contains method. All right, so what are the arguments here? This parameter is the array that has one element, negative 456.7. This is the value 0. And so we are going to try to return true if the array contains that value, 0, and false if it does not. So hopefully we should return false. Check to see if it's null. It's not. We say that the result is false. We step through every element in values. There's only one of them. We check to see is item equal to value? It is not. So we skip the consequence of the if. There's no alternative. We have now gone through every element in the array. Result is still false. So now we're going to return false. We step out of this. All right, now we are about to pass false to debug.assert, and we will see what happens. All right, and we get this incredibly hard to read message here. Right? If you look at this carefully, what it says is at program maximum in, and then the name of the file that I'm in. And then it gives actually the whole call stack of what's happening here, including things that we normally don't see in a call stack. There's a lot of code that runs before the main method runs that sets up the whole environment that makes sure that it works. So these assertions can be quite difficult to read. It also says assertion failed, and this drives me crazy. It says abort equals quit, retry equals debug, ignore equals continue. And then it has buttons down here that say abort, retry, and ignore. This assertion dialog has not changed in at least 20 years. There has always been a version of this assertion dialog, and it always says abort equals quit, retry equals debug, ignore equals continue. I do not understand why Microsoft has not simply labeled these buttons as quit, debug, and continue. It seems like that would be the sensible thing to do instead of having to tell you up here, no, these buttons have different meanings than their labels on them. I don't know why. It's just one of the mysteries of the unknown. All right, so we have three options. If we hit the abort button, then the program will simply stop. We will pop out of the debugger back into the code editor, just as if we'd hit the stop button. If we hit the ignore button, then the program just keeps on running. It ignores the assertion, and we keep on going. If we hit the retry button, then we pop into the debugger. All right, so this is super helpful because it takes you, while you are running the test, right to the point where something terrible has gone wrong. We don't even have to look at the test case. We don't have to start up the program again and step through it in the debugger and get to the broken test case. We are already here, right? So we can now examine the locals, figure out what's going wrong here. Right? And of course, if we now step into our greater than or equal to method, then we go through all of the values here, and we see that, in fact, the item 0 is greater than every value that's in the array. So we're going to return true. And now we're going to pass true to debug.assert, and it does nothing. Okay. You can also give a message to debug.assert. We could say in here, post condition is violated, or have some more descriptive error message in here. And then when the dialog box is created, that message would be in there, as well as the whole call stack. So what's the point of an assertion? Well, the point of an assertion is it is something that you believe to be true of your program. It's not something that you hope to be true. It's not something like, I sure hope that I haven't run out of disk space. Right? You never assert, I haven't run out of disk space, because you don't know that for sure. You make an assertion saying, if my program is correct, if my reasoning is right, then I am going to assert that this condition is always true. So assertions serve a couple of purposes. One is, if an assertion is ever violated, it pops it up in the debugger right where the assertion is violated, so that you can say, something is terribly wrong. It is terribly wrong right here. The second thing it does is, if you are reading somebody else's code, or if you're reading code that you yourself wrote sometime in the past, whereby in the past I could mean before lunch. I have often written some code, gone to get some lunch, come back and said, who wrote this? This is terrible code. Code that is written that has assertions, it documents for the person reading the code what the person who wrote the code believed was true about the code. Right? It essentially helps you put more of the specification into your code in this very sort of active way, right? Where it says, oh, the specification has been violated right here. That is probably a bug. Debug assertions also make you think about bugs earlier. If we had written this post condition in here, if we had said, the value that we return has to be a value that is contained in the array, that might make us think, well, wait a minute. This value right here is not one that is necessarily contained in the array, so why did we even put it into this variable in the first place? Had we written an assertion early, we might have been able to find this bug earlier or prevent the bug entirely. Right? And finally, assertions are really useful because suppose you write some code, you write an assertion into the code. The assertion is genuinely correct. It is always true. It never fires. And then somebody else comes along and changes the code in a way that causes one of your test cases to make the condition false. Right? This really, really helps you find bugs early, because you might have a situation where the code change was wrong, but you didn't really have a test case that exercised everything in a way that would cause the test to fail. Right? But assertions are waving big red flags that say something is wrong here. One final thing before we sum up here. You might say, well, these methods, contains and greater than or equal to all, they look like they could be potentially expensive methods. Suppose this array had millions of items in it. Right? It's one thing to say, oh, yes, this assignment or this check or whatever, this is going to take a few nanoseconds. But you could imagine that these operations could take a really long time, and that adding these post conditions to aid in your debugging would really slow your program down. And fortunately, that is not the case. They do slow your program down while you are debugging. But I mentioned in a video very early in this course that there was this box up here that has debug and release in it. If you select release, then all of the assertions disappear, right? The C# compiler simply pretends that they are not there. It does not run any of the code to evaluate the arguments. It would not run the contains method. It would not run the is greater than or equal to all method. And this is so that you can have two versions of your program, one that is maybe a little bit slower but helps you find bugs early, and one that you actually ship to your customers after you've hopefully gotten all of the bugs out of it. Summing up, the preconditions of a method are the things that have to be true before a method runs at all. The postconditions are the things that have to be true after the method is run. And the right way to think about it is that the postconditions are the things that are true if the preconditions are true. They are dependent upon the preconditions. If a precondition has been met, or if all the preconditions have been met, but one of the postconditions has not been met, then you've got a bug somewhere, right? You've got to find it. You can use debug.assert to assert your postconditions. And you can throw exceptions to reject any violations of preconditions, so that you know that the method will not return normally if a precondition is violated.